Next topic, Taylor series. A function f of x is equal to f of a, write x minus a f dash of a, x minus a whole square by 2 factorial f double dash of a, and so on, is called Taylor series about the point x is equal to a, or I can say around x is equal to a, or at x is equal to a, or in the neighborhood of x is equal to a, or in powers of x minus a. See, for example, there is a Taylor series about x is equal to a. Now we have Maclaurin series. Here Maclaurin series is a special case of Taylor series. If we put a value 0, put a value 0 in the Taylor series, we'll get Maclaurin series, that is f of x is equal to f of 0 plus x into f dash of 0, x square by 2 factorial f double dash of 0 plus x cube by 3 factorial f triple dash of 0 plus and so on. This is called a Maclaurin series, or I can say that a Taylor series about x is equal to 0. Replace a with 0. About x is equal to 0, or Taylor series around x is equal to 0, or at x is equal to 0, or Taylor series in the neighborhood of x is equal to 0, or Taylor series in powers of x. You can say that a Taylor series in powers of x. Now, we'll consider one example. Let us consider we want what is the Taylor series expansion. Taylor series expansion of e power x about x is equal to 0. Taylor series expansion of e power x about x is equal to 0. Means about x is equal to 0 means we have to go for that Maclaurin series expansion. That is a special case of Taylor series. So applying this formula, Maclaurin series expansion or Taylor series expansion about x is equal to 0. Now, so to apply this formula, we require f of 0, f dash of 0, f double dash of 0, f triple dash of 0 and so on. So to find all these, see what is our f of x here? Our function f of x is e power x. Now f of 0, e power 0 is 1. Next finding f dash of x, first derivative is again e power x. Next f dash of 0 is also 1. Next f double dash of x is also e power x. F double dash of 0, second derivative at 0 is also 1. Similarly f triple dash of x, again e power x. F triple dash of 0 is 1 and so on. So now substituting all these values in that series, we get f of x. Here our f of x is e power x, that is equal to f of 0 value 1 plus x into f dash of 0 is again 1 plus x square by 2 factorial f double dash of 0 is 1 plus x cube by 3 factorial f triple dash of 0 value is also 1 plus and so on. So therefore finally I can say that it implies the series expansion of e power x is 1 plus x square by 2 factorial plus x cube by 3 factorial plus and so on. So this is a Taylor series expansion of e power x about x is equal to 0, or I can say that Maclaurin series expansion of e power x. Now I am giving some standard expansions. All these expansions are Taylor series expansions of all these functions a power x, e power x and so on about x is equal to 0. All these are Taylor series expansions about the point x is equal to 0, or I can say that Maclaurin series expansions. Here a power x, e power x, sin x, cos x, sin hx, cos hx, log 1 plus x, log 1 minus x, all these are corresponding conditions. This series is valid for all x belongs to the set of real numbers. All these series are valid for all x belongs to set of real numbers. And here log 1 plus x, that is that series is valid for mod x less than 1. So mod x less than 1. The tan x series is valid for mod x less than pi by 2. Here tan h inverse of x is here I can give this formula. So 1 by 2 log 1 plus x by 1 minus x. So cot h inverse of x, well, tan hx, sin h inverse of x. All these are some standard expansions. So while doing problems, it is better to remember some standard expansions. So all these are Taylor series expansions about x is equal to 0. Now we'll do problems on Taylor series. First problem is the Taylor series expansion of 3 sin x plus 2 cos x is. Here 3 sin x plus 2 cos x, about which point is not given. So here see that options here A, B, C, D all are here in terms of x. In terms of x means you have to expand the Taylor series in terms of x. In terms of x means what is the point about x is equal to 0. So in terms of x or in powers of x. So what is the Taylor series expansion of sin x in powers of x and Taylor series expansion of cos x in powers of x. Here 3 into Taylor series expansion of sin x in powers of x is x minus x cube by 3 factorial plus x power 5 by 5 factorial minus x power 7 by 7 factorial plus and so on, plus 2 into Taylor series expansion of cos x in powers of x is 1 minus x square by 2 factorial plus x power 4 by 4 factorial minus x power 6 by 6 factorial plus and so on. So simplify this one, we will get there is a 2 plus 3x minus x square minus x cube by 2 plus and so on. Simplifying this one. So here answer for the first question is option A, that is this one. Now you see that second question, the Taylor series expansion of sin x by x minus pi at the point x is equal to pi. Here the given function is f of x is equal to sin x by x minus pi at pi. At pi means here about a, the point a is pi here. At pi here, that is a number is not a 0 here. If it is 0, we have to go for in powers of x. So here the number is pi here. So about a, here the a value is pi. So we have that standard expansion. What is the standard Taylor series expansion at x is equal to a? We have f of x is equal to f of a plus x minus a into f dash of a plus x minus a whole square by 2 factorial f double dash of a plus and so on. So that is a basic formula, Taylor series expansion of f of x about x is equal to pi or at x is equal to pi. So to apply this formula, we need to find f of a. Our a is pi here. We need to find f of pi and f dash of pi, f double dash of pi, and so on. And so on. See f of pi. So here f of pi you can find it. What is f dash of pi here? See here, that is a function, is a rational function. So how to find derivative of that function f dash means sin x by x minus pi. You have to go for u by v formula. F double dash, second derivative, and so on. So to apply this formula, it will take a lot of time. To apply this formula, see here f dash of phi, f dash of phi, f double dash of phi, it will take a lot of time. So in this case, we have one shortcut method is there, or we can go for another method. This is a method 1. We can apply that formula, or the method 2 is substitution method. So we need to find expansion of this series at x is equal to pi. So let x minus pi is equal to some variable t. The second method, x minus pi is equal to t. It implies I can write x is equal to pi plus t. X is equal to pi plus t. Now I can write that function like this. It implies, what is that function? I can write f of x function like this. Sin x, replacing x with pi plus t, sin of pi plus t, by replacing x minus pi with t. So now that is a sin of pi plus t. Sin of pi plus t is a minus sin t by t. Now what about series expansion of sin t here? Sin t means, see, We know that what is that series expansion of sin t? The series expansion of sin t, again, that is equal to minus 1 by t into sin t expansion is, we know that t minus t cube by 3 factorial plus t power 5 by 5 factorial minus t power 7 by 7 factorial plus and so on. Here how you got this expansion? See, I'm expanding sin t in powers of t. In powers of t. Why? Because see, Taylor series expansion of sin t in powers of t means here that what about x minus pi? We are taking substitution here. X minus pi is equal to t. X minus pi is equal to t. See here, suppose for t is equal to 0. For t 0, we'll get x is equal to pi, the corresponding point. So I'm taking sin t expansion about t0. For t0 only, we'll get x is equal to pi. So Taylor series expansion of sin t in powers of t or about t0 is t minus t cube by 3 factorial and so on. Now simplify this one, we'll get minus 1 first term, second term plus t square by 3 factorial minus t power 4 by 5 factorial plus and so on. So again substitute t value. What is t here? T is equal to x minus pi. So we'll get minus 1 plus x minus pi whole square by 3 factorial minus x minus pi whole power 4 by 5 factorial plus and so on. So that is the required series. So here that option D is correct. So here important observation is while taking sin t expansion, you have to take in terms of t. That is about t0. About t0. About t0 means that if you take t0 only, you will get x is equal to pi. Taking expansion of sin x by x minus pi at x is equal to pi, which is same as taking expansion of sin t about t0. So answer is option D. Next problem on Taylor series. Taylor series expansion of f of x is equal to x by 1 plus x around x is equal to 0 will be. See here, around x is equal to 0 means we need to find series expansion in powers of x. In powers of x or around x is equal to 0, both are same. In powers of x. So in powers of x, see, given function is f of x is x by 1 plus x. We can do this problem in two ways again. We can do in two ways. We can go for around x is equal to 0 in powers of x. We have to go for that basic formula. What is that? Around x in powers of x means f of x is equal to f of 0 x into f dash of 0 plus x square by 2 factorial f double dash of 0 plus and so on. So we can apply this formula, or we can go for one shortcut method, that is f of x is equal to, here writing x by 1 plus x as x into 1 plus x whole power minus 1. So now we know that expansion here 1 plus x whole power minus 1 is x into 1 minus x plus x square plus x cube minus x power 4 plus and so on. So multiply, you will get x minus x square plus x cube. This is minus plus x cube minus x power 4 plus and so on. So we can go for this formula or we can apply this method. So to apply this method, we should know some standard expansions again. Here we'll go a note. We have 1 minus x whole power minus 1. Expansion is 1 plus x square plus x cube plus and so on. 1 plus x whole power minus 1. 1 minus x plus x square minus x cube plus and so on. 1 minus x whole power minus 2. Expansion is 1 plus 2x plus 3x square plus 4x cube plus and so on. 1 plus x whole power minus 2 expansion is 1 minus 2x plus 3x square minus 4x cube plus and so on. 1 minus x whole power minus 3 expansion is 1 plus 3x plus 6x square plus 10x cube plus and so on. Similarly, 1 plus x whole power minus 3 expansion is 1 minus 3x plus 6x square minus 10x cube plus and so on. If you remember, these are standard expansions, so that we can apply that shortcut method. So all these expansions are valid for mod x less than 1. All these expansions are valid for mod x less than 1. So answer for that third question is, we will get option D, x minus x square plus x cube minus x power 4 and so on. Now if you come to that fourth question, in the Taylor series expansion of e power x plus sin x about the point x is equal to pi, the coefficient of x minus pi whole square is. So to solve this question, we have to go for basic definition. What is that basic definition? We have f of x is equal to f of a plus x minus a into f dash of a plus x minus a whole square by 2 factorial f double dash of a plus x minus a whole cube by 3 factorial f triple dash of a plus and so on. So here the point A is pi. Here we require about x is equal to pi. So here the point A is equal to pi. A is equal to pi. We require coefficient of x minus pi whole square. Where we get x minus pi here? Here the corresponding, we replace x with A with pi. We get x minus pi whole square by 2 factorial f double dash of pi. The coefficient of x minus pi whole square is this one. This is the coefficient of x minus pi whole square, that is 1 by 2 factorial into f double dash of pi. So now finding that value, that will give the final answer. Here the coefficient of x minus pi whole square is 1 by 2 factorial into f double dash of pi. Now what is f of here? To find this f double dash of pi, so what is the given f of x here? Given f of x is a function e power x plus sin x. Find first derivative and second derivative. So the first derivative f dash of x is e power x, sin x derivative cos x. Next, so finding second derivative f double dash of x, e power x minus sin x. Now finding f double dash of pi, replacing x with pi, will get e power pi minus sin pi. So here sin pi value 0, will get f double dash of pi is e power pi. So now that is equal to 1 by 2 factorial means 2 only. 1 by 2 into will get e power pi. So 1 by 2 into e power pi, or I can write 0.5 into e power pi. So for this question, the answer is option B. Next problem on Taylor series. For the function e power minus x, the linear approximation around x is equal to 2 is. See, what do you mean by linear approximation around x is equal to 2? So if we consider that the Taylor series about x is equal to a, f of x is equal to f of a plus x minus a by 1 factorial f dash of a plus x minus a whole square by 2 factorial f double dash of a plus x minus a whole cube by 3 factorial f triple dash of a plus and so on. The Taylor series of f of x function about x is equal to a, or at x is equal to a, around x is equal to a, or in powers of x minus a, or in the neighborhood of x is equal to a. Now we require linear approximation of that function around x is equal to 2. So linear approximation means here linear approximation of any function will be like this. To get linear approximation, we have to remove powers of x square, x cube and so on. So we have to remove this part. So this only sum of these two terms will give the corresponding linear approximation. Is taking up to only linear term. X minus a is a linear term. So what is the degree here? Degree of x is 2, 3, and so neglecting all those higher powers of x, that is starting from 2, 3 and so on. So taking up to only linear term. That is linear approximation. Similarly, what about quadratic approximation? Quadratic approximation of f of x is, I can write like this, f of a plus x minus a by 1 factorial f dash of a plus x minus a whole square by 2 factorial f double dash of a. So taking up to third term and neglecting remaining terms, that will give the quadratic approximation of f of x. Quadratic approximation of f of x. Now if we see the first, that is the fifth question, here the function is f of x is equal to e power minus x. We require linear approximation around x is equal to. Around x is equal to means here our a value, here given a value is 2. Given a is equal to 2. Given a is equal to. Therefore I can write here to apply this formula, see f of x is equal to e power x. That is equal to, I can write f of 2 plus x minus a. Here x minus a value is 2. X minus a by 1 factorial f dash of a is 2. So that will be the corresponding linear approximation of e power minus x. So simplify this one, we get answer. So what is our f of x e power x? What is f of 2 e power minus 2 plus x minus 2 f dash of 2. Here f dash of x is derivative of e power minus x is minus e power minus x. So it implies f dash of 2, replacing x with 2, minus e power minus 2 again. So we get minus e power minus 2. Minus e power minus 2, that is equal to, I can write, that is equal to e power, taking e power minus 2 common, you get 1 minus x plus 2. So e power minus 2 you get into 3 minus x. So that is the corresponding linear approximation of that function e power minus x around the point x is equal to 2. Now if we come to that sixth question, here we require quadratic approximation of that function at the point x is equal to 0. At the point x is equal to 0 means that is the series is corresponding series will be in powers of x. The corresponding series will be in powers of x. See here already the given function is in expanded form in powers of x. Given function is in expanded form in powers of x. So we require quadratic approximation. Quadratic approximation means simply here remove that x cube term, x cube and remaining terms x power 4. Here there is no x power 4, only highest power is x cube. So remove that one, we will get corresponding quadratic approximation f of x is equal to minus 3x square minus 5. So this will be the corresponding quadratic approximation of f of x. Quadratic approximation. Why I am removing here x cube term here directly? Because the function given in expanded form around point x is equal to 0, that is in powers of x. Or even if you go for that formula also, that will give the same answer. Applying that formula, see. Or the second method is applying that formula. What is that formula? F of x is equal to, here what is our point here? X is 0. X is 0 means we will get applying that formula f of 0 plus x minus a means x by 1 factorial into f dash of 0 plus x square by 2 factorial into f double dash of 0. So even applying this formula also, that will give same answer. Here we will get minus 3x square minus 5. Here the given function is what is our function f of x? F of x is x cube minus 3x square minus 5. So whenever given function is already in expanded form, to get approximation we can do directly like this, no need to go for this formula. So answer for this question is minus 3x square minus 5. That is option B is correct. For the first question, answer is option A, 3 minus x into e power minus 2.